In this video, we're going to be talking about what's called the unit circle. And the reason why it's called the unit circle is because each of its radii lengths, the length from the center of the circle to any of its outside points all the way around the circle, is going to be 1 unit long. So from the center to this point right here is 1 unit long. If I draw another radius from the center of the circle to any point outside the circle, that is 1 unit long. So that is why it's called the unit circle. The unit circle allows us to simplify a lot of trig expressions and really expand into the realm of trigonometry. And it's pretty important to understand the unit circle in order to go any farther in trigonometry. However, you need to understand your right triangle trigonometry in order to really do anything that we're about to do. So if you don't understand your right triangle trig, make sure you go back and review that. You can look at my videos or look in your math book. But we're going to be using some of our knowledge and applying it to the unit circle. So here we go. In the unit circle, we draw this circle on a coordinate plane. So we still have our quadrants here. We still have quadrant 1 in the upper right corner. We still have quadrant 2 over here in the left top. We still have quadrant 3 down here. And this is still quadrant 4. And we still have our x and y axis. This is still our x axis. This is still our y axis. These are still horizontal values, and these are still vertical values. So what we're going to do is we're going to draw a right triangle in the first quadrant and explore some unique things that happen in a unit circle. So here's a right triangle sitting in quadrant 1. The length of the bottom of the triangle is that x value from here to here, and the length of this side of the right triangle is going to be the y value from there to there. And what ends up happening is that we intersect our unit circle at a certain point, and those coordinates are actually whatever the x and y values of our triangle are. This radius is always going to be equal to 1 unit. That's going to simplify our trig functions, as we will see. So if I wanted to find the sine of an angle, let's say that we're looking at this angle inside the triangle right here. Hopefully you remember from your right triangle trigonometry that that is equal to opposite over hypotenuse. Well, the hypotenuse is a value of 1. So what ends up happening is it's just the opposite side divided by 1, and anything divided by 1 is just itself. So the sine of that angle is just the value of the opposite side. Let's transform that just a little bit further here. Let's take it now in terms of x and y, since we're talking about our coordinate plane. So this side is our x side, this side is our y side, and so now the opposite side is our y value. So we can rewrite our expression as the sine of that angle is equal to y divided by r instead of opposite divided by hypotenuse. And since r is 1, the sine of that angle is really just the y value. And so we can think about that as the y value, or the length of this side of the triangle, or we can simply just say it's the y coordinate on the unit circle. So what ends up happening here is it gets simplified down to the sine of that angle is just y, the y coordinate, or the y value. And so that is what we're going to end up using a lot more in the future. We can do that with all 6 of our trig functions, and so I'll describe them all as we go here. The cosine of an angle is usually thought of in right triangle trigonometry as adjacent over hypotenuse, and in this case it would just be adjacent because our hypotenuse value is 1 still. And if we apply that to x and y values, we have the cosine is equal to x divided by r. And since r is 1, the cosine of the angle is just the x value, the x length of the triangle, or the x value of the coordinate intersected at that spot. And so we say the cosine on a unit circle is equivalent to our x value. Tangent is a little bit trickier. I'm going to erase all this. Talk about tangent. Think back to right triangle trigonometry. Tangent is equal to opposite over adjacent. Tangent of an angle is equal to opposite over adjacent. And so we need to apply that to our unit circle. Instead, we're going to write opposite is the y, adjacent is our x. So the tangent is actually equal to the y coordinate or y value divided by the x value. This is a rational function. It's a rational expression. And so anytime we talk about rational expressions, we always define them saying that our denominator cannot be 0. So in this case, the tangent function is undefined if the x value is 0. So we have to put that in there. Alright, so those are the three basic trig functions. Let's talk about our reciprocal functions. Let me get rid of this circle. Get a new one up here. Alright, one more time. Draw a right triangle. Here's our angle. Let's talk about our reciprocal functions. The first one, the reciprocal of sine, is what's called the cosecant. And the cosecant, shorthand is CSC. So the cosecant of an angle is the reciprocal of sine. Remember that the sine of an angle is equal to y we just defined. So the reciprocal of that is just to flip it. We would write y over 1, right? So the reciprocal would be 1 over y. And again, we're going to define it so that y cannot be 0, otherwise it's undefined. We can do the same thing with our cosine. So cosine was equal to x, or x over 1, right? Well, the reciprocal is called the secant, and that is spelled shorthand, SEC. So the secant of an angle would be the reciprocal of that, 1 over x. And again, we're going to say that x cannot be 0, otherwise it's undefined. And a common mistake here is that a lot of students will confuse these two reciprocal functions because they want to say that secant looks a lot like sine, and so it would make a lot more sense if sine and secant were reciprocals. And in a nice universe, I suppose that would be the best thing, but it's not the case. So try to get that out of your head as quickly as possible, that the reciprocal of sine is cosecant, and the reciprocal of cosine is secant. Alright, let's talk about tangent. So tangent we defined as y over x, where x could not be 0. This one's easy. The reciprocal is called the cotangent, so that makes sense. And that shorthand is just COT. So if we just flip that, make it a reciprocal, we have x over y, and we just say that y cannot be 0, otherwise it's undefined. So there's our 6 trig functions. A lot of times problems in a book will ask you to define all 6 trig functions. So that's what you basically have to do. And some problems can come from trying to simplify these ratios when you actually substitute values in there. So we might do some examples in our next video here. I'm just going to try and work on the unit circle in this video. Alright, one more thing we have to talk about is working our way around the circle. So what we just defined is everything in this first quadrant where our x values are positive and our y values are positive. Things start to get a little bit different as we move into the second quadrant and the third quadrant and the fourth quadrant. So let's do that next. Alright, let's draw a right triangle in the second quadrant and see how it changes our signs of our trig functions. And that's really all that changes, is just the sign, whether it's positive or negative. The fractions or ratios will still be the same. So sign is still going to be, oops, let's put our angle, we're talking about that angle right there. Sign of that angle is going to be still y. It's still the y value, because our y values are still going up. So if we intersected at this point, that's going to be a positive y, and so our sign is going to be a positive y still. What's going to change next is the cosine, though, because if we move left on our coordinate plane, we're getting into negative values, so this ends up being a negative x value at this coordinate. And so our cosine ends up being a negative x value. And then if we talk about tangent, that's going to be a ratio of y over x, but now our x is negative, so that makes the whole fraction negative, because a positive divided by a negative would be a negative. Never leave that negative in the bottom or denominator position. We always write a negative sign in front or on top. All right. And so then our reciprocal functions would look similar. Sine is still going to be 1 over y. That's going to be positive, and y is undefined if it equals 0. Oops, I'm sorry, we're talking about cosecant there. Well, let me start over. The reciprocal of sine is the cosecant. That would be 1 over y. There we go. The reciprocal of cosine is secant, and that is equal to 1 over x. But now, because we're in the negative x values, we have a negative 1 over x, and again, x is undefined if it equals 0. And the cotangent, the reciprocal of tangent, is going to be x over y, and again, our x values are negative, and again, y is undefined if it equals 0. Alright, so that's everything in quadrant 2. Just the x values are negative. Let's talk about quadrant 3. Draw another right triangle, this time in quadrant 3. And it's going to look something like this. And we're talking about this angle. So now we have negative x values. So this point would intersect at a negative x value. And now we're going down on the coordinate plane, so now we have a negative y value. So the coordinates would be both negative if we were talking about a point on the circle in that quadrant. And so we would have, let's see, sine would be negative y, cosine would be negative x, tangent would be negative y over negative x, and a negative divided by a negative means that we have a positive y over x. So tangent in quadrant 3 is the only positive function. And then our reciprocal functions, cosecant would be negative 1 over y, and y could not equal 0, otherwise it's undefined. Secant would be negative 1 over x, and x could not be 0, otherwise it's undefined. And cotangent would be negative x over negative y, so again the reciprocal cotangent function is positive, just x over y. And I'm running out of time real quickly, so I'm going to extend this into the next video, and we'll keep talking about our unit circle.